about slope-intercept form. Slope-intercept form is one way that linear equations can be written. It's a common way. And what this allows us to do is to see different parts of this equation and be able to graph it and understand what it's doing at a very simple first glance. A slope-intercept form is written with the black parts here, the y equals x and plus is not really changeable. Okay, those are going to be pretty common from form to form. Sometimes the plus will be a minus, but we'll get to that in a minute. What is going to change between different equations are the value that's being multiplied by the x here, which we call m, or the slope, and the b value. Sometimes when the b value is negative, it can be something x minus another number, but that would just be the same as if you said something x plus another number. Now, those two values will affect how quickly the line goes up and down, sort of the slant of the line, right, in this way. So let's give you an example. Let's take the equation y equals, now I'm going to go ahead and color these in here, but let's say I have y equals 2x plus a negative, actually, you know what, that should be red, shouldn't it? Kind of stick with my theme here. All right, so we'll go 2x plus a negative 2. Now let's say negative 3. Right. So in this case, I look and say, okay, the 2 is in front of the x. It's being multiplied by the x. And that is going to represent my slope. Right. The negative 3 is the number being added to that x term, and that's going to represent my y-intercept. And we can again get these numbers simply by looking at the equation. Okay. So in order to graph this, what we do is we take those two values and we're going to start plotting points. This y-intercept is basically like our starting value. I'm going to write that in quotes because technically there is no starting value since this is a line, since lines are infinitely long. But if you're dealing with a real world problem where negatives may not make any sense, then this is often thought of as a starting value, right? And so what we do is we take that number and we put a corresponding point on the y-axis, right? On the line that goes up and down here. So I'm going to place the negative 3 right there, or place a point, I should say, right there. And that's going to be my, not technically starting value, but my anchor point. That's how I'm going to start drawing the line. All right. And that would be at negative 3. Now, from there, I'm going to travel based on the slope. Right? So the y-intercept is a starting point, and the slope gives me a value indicating how I travel along this line. So in this case, what I'm going to do is I'm going to start at negative 3, and I'm going to go vertically this slope amount every time I go over by 1. So I go, and I have my first point that I'm going to draw in there. There are an infinite number of points in between those, but don't worry much about that right now. We'll come back to that later. And then I keep going. Up 2, over 1. Up 2, over 1. Up 2, over 1. Now, I don't have to draw in all those little dot, 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 dot. What I want to do is draw in those points until I get enough points on there that I'm able to connect them all with a line, with an enormous line like this. Let's see if I can kind of shrink it down a little bit. All right. So that's my line. And that technically, well, it should go a lot longer than that, but all right. Our line is infinitely long. If I'm drawing this right, like that. Infinitely long in both directions, like this. Okay. Now all those points on there represent potential solutions to this equation. Every little tiny point in between those points. Any 2 points, there's an infinite number in between them. So I could take the x value for 1.01 and plug it in, and I would find something that's a little bit above that. Okay? But this gives me the pattern, the general trend, and allows me to graph that line. So let's take another example here. We'll draw it on the same one because I don't want to have to go through and recreate it in the middle of the video. Right? And let's take y equals, let's use a negative slope here and make it a fraction because we'll see fractions a lot. Let's go negative 2/3 x plus, and we'll make it 5. So if you're looking at this, you can immediately go, okay, our slope is going to be negative 2/3. That's going to be our slope. And this 5 will be the y-intercept. And again, that is where our line is going to cross that axis. I'm going to make my line green just to kind of distinguish, and I'll put it over here like this. And you know what? I'm going to change my, all of my colors here because again, right? So for the green line, I'm going to start again at the point y equals 5. So I'm going to come up here on the axis and find out where my height of 5 is. 1, 2, 3, 4, 5. Draw a little dot there. That's my starting point, my anchor point of this line. It's where it crosses over that y-axis. Now, I have a fraction. Now, if you remember the slope, in order to graph this, we would take the slope and go this many over, or this many down, I guess because it's a negative, every time we go over 1. So if this number is negative, you're going to be going down over 1. And if this number is positive, you would be going up like we did on our black line here. But trying to eyeball it at a fraction is not really going to work for us. So what we're going to do is we're going to take a very common little shortcut. We're going to look at this fraction as 2 parts. We have a rise divided by a run. Okay? So when I do that, what that means is that if I start at my 5 here, which actually should have been blue, bucket fill, so that I don't get this confused, right? And then I'm going to go down 2 while I run by 3. So it's going to go like this. I start here, I go down 2, oops, oh, that's right. So I'm going to go down 2 while I run 3. And my new point is going to be right there. Down 2, over 3, like that. Down 2, over 3. Now notice that if I move the negative down here to the bottom, right, it would be the same thing in this case as going up 2 and backwards 3. Right? Positive 2 vertically, negative 3 horizontally. Positive 2 vertically, negative 3 horizontally. And you'll notice that that continues along on the same path. So I'll take my line here and I draw. And that gives me, oh, that should be green. Oh, that gives me my green line. Now, interestingly enough, and in future videos, you'll see when you have 2 lines that intersect, the point that they intersect happens to be a solution to both of those lines. So when we talk about later on, when we talk about solving systems of equations, that point right here, in this case, 3, 3, will solve both of these lines. If I plug in 3, it'll make both equations true. So 2 times 3 is 6, minus 3 is 3. Negative 2/3 of 3 is negative 2. Negative 2 plus 5 is 3. So it'll solve both of them, but that's getting a little ahead of ourselves. The idea here is that we are graphing based on those two parts whenever we use slope-intercept form.